Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby.
For this episode, I talked with Kai Starn and Catherine Paplin. They're my colleagues here at Stephen Winter Associates. Kai focuses mostly on green building certification for larger commercial buildings, and Catherine works on building enclosures, high-performance building enclosures, also for bigger buildings. And we're talking about embodied carbon, and this is an issue we're seeing more and more different places. When we talk about carbon, we're talking about greenhouse gas emissions. CO2, carbon dioxide is the biggie, but there's also methane, nitrous oxide, and halogenated hydrocarbon gases, HFCs, refrigerants, blowing agents, etc. When we talked about carbon until fairly recently, most people were talking about operational carbon. A building uses energy. A lot of energy is generated by fossil fuels. Burning fossil fuels gives off CO2, and that was what we're trying to reduce. When we're talking about embodied carbon, we're talking about the materials themselves and the building itself, the material extraction, processing, transportation, construction. When you analyze the whole carbon picture, people who do it rigorously do life cycle assessments, or LCAs, which is a pretty rigorous analysis. We're not getting too deep in this discussion, but this is a quick conversation to talk about why and how and where we're seeing this embodied carbon issue come up more and more. We're all seeing it more and more. If you want to learn more, A, check out our show notes. Catherine and Kai link to some great resources. And B, if you can make it to Boston later in March, I encourage you to check out NESE's Building Energy Conference. NESE is the Northeast Sustainable Energy Association. March 23rd and 24th at the Westin Boston waterfront. I think I've missed one of these Building Energy Boston conferences over the past 20 years. I've gone for quite a while. I'm looking forward to this year. A colleague and I, Nicole Ceci and I, are doing a session on building electrification called To Electrify or Not to Electrify. It's a discussion or perhaps a debate on prioritizing electrification efforts, building electrification efforts. I'm looking forward to that. And also, I just looked at the program, and there are 3 sessions focused on embodied carbon. This has been a hot topic at NESE for the BE Boston for the past few years. So come check that out if you can. March 23rd and 24th, 2020, Westin Boston waterfront. Go to nesea.org, nesea.org, for more info. In this conversation with Catherine and Kai, we started discussing why we're hearing more about embodied carbon these days.
We now have evidence that the amount of carbon emissions from a building during its whole life cycle, on average, 30% of that is from embodied carbon, is from building the thing. And if you're looking at a 30-year projection, then the first 30 years of the building's life, then you're looking at 50% of the emissions that will be due to that building being the result of embodied carbon. And all of those emissions are going in before the building even begins to be used. So it's already there in reality by the time that you're starting to use that building. And that is a huge thing to think about when you start looking at the horizons that are projected for climate change acceleration and possible tipping point.
Yeah, so if reducing carbon emissions, carbon dioxide equivalent emissions is a priority. This is definitely something you should be looking at. That's huge. So basically it takes constructing a building results in as much emissions as it does as the building operating over the first 30 years.
Yep.
Very generally, obviously very generally speaking.
Yeah, and this is based upon the, I believe, 2018 UN report on climate change and environment emissions. So this is top scientists in the world coming to a consensus about this number.
Gotcha. So that's worldwide. That's a worldwide number?
Yes, it is.
Okay, cool. And Catherine, you wrote a blog post on our site a while back about embodied carbon associated with different insulation materials. And that's kind of eye-opening because obviously a key way to reduce operational carbon is to add more insulation. But some insulations have really big embodied carbon implications. Can you talk about that a little bit?
When you're talking insulation, it turns out that more is not always better because there are types of insulation which are extremely commonly used, namely plastic foams. And there's a rigid plastic foam board commonly called XPS for extruded polystyrene. There is a spray foam plastic insulation closed cell, which is also used all over, and both of these are manufactured and, in the case of the spray foam, installed with a hydrofluorocarbon blowing agent. And that blowing agent has something like 1,200, 1,400, there are different estimates, but they're all in the well over 1,000 range, times the global warming potential of carbon dioxide. So when we talked about those equivalent gases to carbon dioxide, this is one of that 2% of emissions gases that are completely out of proportion in terms of the amount of carbon emissions they actually represent. So what that really means is that when you go and put something like this, if you put just 1 inch of this insulation into your building, it's going to be 36 years, 40 years, it depends, there are different calculations, but in that range, before you pay off, before you have saved all of the emissions that you just spent in putting that in there.
It's a crazy number.
1 inch is not enough insulation.
Yep.
So in reality, it's decades and decades before you have made up for what you spent putting that in. I'm sorry.
No, that's great, and it's a huge number, and it's kind of jaw dropping. And I mean, are you seeing a move? I mean, there obviously cellulose comes to mind as what I would think would be the lowest, one of the lowest embodied carbon insulation. But is that accurate? First of all,
it is certainly among the lowest. What you get into with insulation and with all materials is there's a reason why we're using these things.
Yeah.
There's a reason why this is the most commonly used material or one of the most commonly used materials for insulation, and that is because it does so much so well. It gives you, those two insulations give you among the highest R value, that is resistance, thermal resistance value per inch of any insulation. And they have other qualities that make them extremely useful, even sometimes indispensable for particular uses. The spray foam is a vapor barrier, it's an air barrier, it conforms to any irregularities, and on and on. So,
yeah, no, like you say, this is, I mean, foam insulation is so appealing for so many reasons, and it has been the go-to for many different applications of people on the leading edge of high performance buildings. And now maybe that will change a little bit. And we'll put a link to your blog post and some of your sources for that.
Sure.
in the show notes. But it's a huge, things are changing.
I just sort of want to reiterate sort of what we've been talking about. It's really fascinating, and it's a really big deal talking about this carbon that's front-loaded into the buildings before we even move in. And, I think what we're sort of talking about when we're talking about these installations and stuff are, high-performance buildings. We want our buildings to operate at a low cost, and, that's been the forefront of our minds since the 70s, of energy efficiency. And we're starting to realize that these high-performance buildings with these high embodied carbon materials release more total emissions than, maybe a code minimum building with, moderate embodied carbon emissions. And it's a really big deal and sort of startling. And, we absolutely need these, we're talking about net zero energy buildings in the industry a lot, and we absolutely need those, and we're not disputing that. As Catherine said, these materials have properties that we need in areas, but just looking at the net zero by itself isn't going to get us to the goals to stabilize the temperature of the climate in the time frame that we're looking at.
Yeah. So in your work, Kai, are there a few materials? You've done a little bit of number crunching, building by building, I think. And what are the big, what are the big components that are big problem areas or big opportunity areas to reduce embodied carbon?
Yeah. I mean, the short answer is to choose lower carbon materials, and we can maybe get to that later, how to do that. In maybe using carbon sequestering, natural materials. Also, part of that short answer is just to use less material overall. That's one thing that we can look at early on, different massing options. But in the industrialized areas, the three main structural materials, concrete, steel, and wood, are the drivers of embodied carbon by virtue of just how much fuel and energy it takes to create them, to bring them into existence.
Yeah. Kai, maybe I'll ask you. I mean, programmatic-wise, what are you seeing? How are you seeing kind of your clients or programs starting to address embodied carbon? Yeah.
So in my world, I work a lot with green certifications, building certifications, primarily LEED. And the LEED version 4 building rating system really has been the biggest market driver, up till now, related to embodied carbon, in my view.
So people are starting to, a few people are starting to pay attention in the context of programs. It's just credits right now that people may or may not go after, but people are starting to look at it. Is that fair?
There's a growing consensus that overall zero carbon needs to be our goal across the industry. And, we've heard that from Architecture 2030, who stated that the construction industry needs to be net zero carbon by 2050. Sooner's better, But that's sort of the outer goal.
And are those goals explicitly embodied and operational carbon?
That's right. Yeah. So we'll be looking at both those pieces. Yeah.
Okay. Cool. Nice. And Catherine, on the, what are you seeing on the policy side or among clients about interest in embodied carbon? Or what would you like to see? Maybe is another question. It's a different question, perhaps.
One of the most important things at this point that we could do when we really look at embodied carbon is to make a shift in our priorities from building new buildings as the first thing that we want to do all the time to renovating existing buildings as the first thing we want to do all the time. Because it's a very simple and obvious thing that if you don't take down a building and build something else in its place, or even just build a new building, but especially if you take an existing building and you dismantle it, you destroy it, and build something else, it's obvious how exponentially more embodied carbon you are putting into the atmosphere at that point. It's tremendous, and we really can't afford to do that anymore.
Yeah, this is a huge issue, and I mean, we've all run into that, I'm sure, with clients who want to build new rather than renovate, and it's much harder. I mean, that there's you were talking about insulations, Catherine, with foam insulations have a lot of advantages. Starting from scratch with new construction makes it easier to, get good efficiency, get accessibility, durability, resiliency. All of those are easier when you start from scratch. But this is a huge deal about the embodied carbon of that construction.
Well, I think one of the misconceptions that should be dispelled is that older buildings are less efficient or automatically less efficient or have considerably less capacity to achieve high efficiency, high performance. I think that what we're showing more and more now is that in fact we can make older buildings high performance, high efficiency, and you have to get into also a discussion, which we don't have time for here, about what age of buildings, because over the past 100 years, construction and 150 years, construction methods have changed radically. Scale has changed radically, and there's a different approach for each era of building. But for example, you will find that it is often easier for pre-war buildings to be brought into a high-performing status than some 50s through 70s buildings.
So pre-war, we're talking about New York City before World War II, generally. Okay, yeah.
Yep.
Pretty clear demarcation in the city.
But at the same time, there is now a lot of work afoot to figure out how to make those 50s through 70s buildings be retrofitted to perform well. One of them, there's a lot of focus, of course, on curtain wall now, because we're going to have to deal with aging curtain walls.
Yeah, boy.
There is also options like interior storm windows that people don't necessarily know a lot about yet, but these can be operable, and you can even have basically interior curtain wall replacement that prolongs the life of your curtain wall building and gives you a huge bump in performance.
Yeah.
Thinking, just sort of mulling over the existing building conversation, it's real interesting. Thinking about why building owners may opt to keep the building instead of tearing it down and building new. And I would imagine that one of the drivers is cost. It's more cost effective to reuse these buildings in certain instances, and it makes me think of something that our clients often ask us is, they ask for a life cycle assessment when they really want a life cycle cost analysis. And, I think what they're looking at is, okay, well, what materials are we going to use? How much is it going to cost us? How long are they going to last? This sort of thing. And, both employ this like life cycle approach, where the life cycle costing, the LCC, is the direct monetary cost for a product or service, whereas the LCA is the environmental benefits. And they actually can, if you're doing life cycle costing, you're not so far off from doing a life cycle assessment too. You're collecting your materials, you know how much your material quantities you're using, and it's not so difficult to transpose those into the environmental benefits. And I hope that more of our clients start asking for that.
Yeah.
We're watching buildings get torn down every day. It's really time to start thinking about the fact that buildings aren't disposable. We really have made this in our minds into a disposable product, and it's not.
Yeah.
And the poster child for this, as far as I'm concerned, would be 270 Park Avenue, which is a high-rise, international-style commercial building, skyscraper that is being torn down as we speak. It is the largest such demolition, at least ever in New York City, and it may be in the nation or the world. I'm honestly not sure, but it is being demolished in order to make way for a new, larger skyscraper. And if somebody analyzes what kind of embodied carbon hit this represents, I think that this ought to become what Penn Station, the demolition of Penn Station, was to the historic preservation movement. It's a wake-up call that we can't afford to think like this, because we won't achieve our goals if we continue to do this.
Thanks to Catherine and Kai. And again, I urge you to visit the show notes page. There's lots of resources. There's links to the Embodied Carbon Network, the relatively new EC3 tool, Architecture 2030, several reports, blog posts about embodied carbon, about historic preservation. We decided to link to all these in the show notes rather than have Catherine and Kai rattle them off in the audio. Also go to nesi.org, check out the Building Energy Boston Conference if you can, March 23rd to 24th, 2020. And one maybe sobering note, since we recorded this, according to Wikipedia at least, we confirmed that 270 Park Ave is indeed the tallest building ever to be voluntarily demolished in the history of the world. So, sorry we're not ending on a high note. Thank you for listening. Buildings and Beyond is produced by Stephen Winter Associates. Visit swinter.com for more info on us. Visit swinter.com/podcasts to get to all our episodes and to see the show notes. And visit swinter.com/careers to see job openings. We have quite a few across all our offices: Connecticut, New York City, Washington, D.C., and a new office in Boston. I've been here for just about 20 years now, and it's pretty amazing working with brilliant people who really care about making great buildings, improving sustainability, accessibility, health, affordability, durability. It's a pretty fantastic crew. Thanks to the podcast team here: Alex Miraboli, Heather Breslin, Dylan Martello, Jade Alvarez, Kelly Westby, and I'm Robb Aldrich. Thanks for listening.